I am Anil Kumar. Welcome to my series on quadratic functions. We'll try to find equation of a parabola from the given graph. Here are a few basics which we should understand before getting into writing equations. Equation of a quadratic function could be written with the parent function y equals to x squared in different forms. One of the form is called the standard form, where the equation is written as y equals to ax squared plus bx plus c. Vertex form, y equals to a x minus p whole square plus q. Intercept form, y equals to a x minus x1 times x minus x2. From the standard form, you can find the y-intercept. From the vertex form, you can find the vertex. And from the intercept form, you can find the intercepts. These are the key parameters which we should keep in mind while working with quadratic functions and their graph, which look like a parabola. Graph of a quadratic function is a parabola. Steps from vertex are a times 1, 3, 5, 7. I will elaborate on this point as we write the equations from the graph. The second difference is constant for quadratic functions. As you know, first difference is constant for linear functions. Now let's take up characteristics of quadratic functions. In question number 1, we'll try to read the information from the graph. Here is a graph given to you. We need to describe the characteristics and key parameters of the function from the graph. So to find the characteristics, let's identify few important points. One of them is vertex. The coordinates of vertex are -1, 2. Let me write down here. -1 and 2. The y coordinate. Then we have x and y intercepts. X intercepts are at -3 and at 1. The y intercept is at 1.5. So let's write down those points also. So this is 1.5 for us. Now with these identified points, we can write many characteristics of the parabola. To begin with, as we see the parabola, we can say that the parabola opens downwards, right? Opens down. Now when a parabola opens down, then the value of a has to be less than 0. It is negative. Now the second characteristic is that it has vertex at -1, 2. So that means that the maximum value is 2. So the maximum is 2. So that actually gives you the range of the function, right? So the range of the parabola is y less than equal to 2. As far as the domain is concerned, there is no restriction, right? So the domain is x belongs to real numbers. The x-intercepts are at x equal to -3 and 1. The y-intercept is at y equals to 1.5. Now parabola also has axis. Axis of symmetry is the line on which the vertex will lie. So in this particular case, That is the axis of symmetry. Equation of the axis of symmetry is what? The equation of this axis of symmetry is x equal to minus 1. So we can write down here axis of symmetry, in short, x equals to minus 1. When we say it is symmetric about this point, it really means that if I have any point on the left side of this, then we'll have a mirror image on the other side. So that is what the symmetry is about this axis. Now there are many ways of writing equation of this particular parabola. The easiest, of course, will be using the vertex. We could also write the equation using the x-intercepts in this particular case. Now, to find the equation, what we can do here is, since we know that at minus 1 the value of y is 2, but at 0 it is 1.5, that means that in one step it goes down by 0.5. Right? So this is one step to the right, it goes down by 1.5. Since it goes down by 1.5, the value of a is equal to minus, because it goes down, 0.5 is half. So that is how you can get the value of a without many calculations straight from the graph, right? The next step will be minus half of 3. We can write down this equation now as y equals to minus half x minus the axis, which is minus 1, so it becomes plus 1 whole square plus the maximum value, in this case 2. So that becomes the equation of this particular graph. As you can see, if we understand the characteristics, we can easily find the equation without many calculations. We'll explore this in details in the coming portion of this video. So let's get to writing equations now. We'll take up a very simple case. Here in question number 2, we will write down equation in the standard form, which is y equals to ax squared plus bx plus c. Question number 2 here is, write equation of the parabola shown in the figure below. Let's identify the key points from the graph. One of them is the vertex. The vertex here is at 0, 2. The other ones are the x-intercepts, which are at plus and minus 1. So you could actually write this equation in any form. Since we know x-intercepts and the vertex itself, let's start by writing the equation in the vertex form. So I'll begin with the vertex form. Which is y equals to a times x minus p whole square plus q. The value of q is the axis of symmetry, which is 0. The value of q is 2. The value of p is the axis of symmetry, which is 0. And the value of q is the maximum value, 2 in this case. So we could write this, since we know that the vertex is 0, 2, we could write this equation as y equals to a times x minus 0 whole square plus 2, which is y equals to ax squared plus 2. Now to find the value of a, we can use the concept of step. If I move one step to left or right, let's say one step left, I go 2 units down, right, since this value is 2. So I know that the value of a should be equal to minus, since we are going down, 2, right. That is one way of doing it, right. This is one method of doing it. There is another way of finding the value of a, and that is that we could use one of the points. In this case, we could use the x-intercept, which is at 1. So we know the point on the curve is 1, 0. So if I substitute this point, y is 0 for us, right? The x value is 1. So if I write 1 here, right, for x, then I can calculate the value of a. So in general, that is how you will be finding a. So from here clearly, we can take 2 to the left side. So get minus 2 equals to a. So we get the value of a, which is exactly same as what we had anticipated. Do you see that? So as I was saying, we could write the equation substituting the value of a here as y equals to minus 2 x squared plus 2, right? So that becomes the equation of this parabola in standard form. So I hope you also appreciate that reading the value of a by checking the steps is a very critical step, and we can actually find the equation quickly using this particular concept. Let's move forward and take the next example now. This time we have a parabola which is opening upwards, and it has a vertex right there. The vertex is at x value is 1 and the y value is minus 6. We need to identify other points on this parabola. The best point here is the y-intercept, which is at 0, minus 5. So these two are good points to get the equation of this parabola. So we know that the vertex in this case is, let's call this as v, which is 1 minus 6, and we have the y-intercept in short. So y-intercept, let's say we call this point as b, 0 minus 5. Since we know the vertex, we can straight away write down the equation as y equals to a times x minus x value of 1 and the minimum value minus 6, and that is square. Perfect. To find the value of a, we can use the y-intercept. So we'll use y-intercept to find the value of a. That is to say that we'll substitute the value of x as 0 and the value of y as minus 5 and calculate a, right? So we get minus 5 equals to a times 0 minus 1 whole square minus 6. Bringing 6 to the left side, we get minus 5 plus 6 equals to a, or a is equal to plus 1. Let us check with our concept of steps. If I move 1 unit left, I am going 1 unit up. So a equals to 1 since 1 step up, right? So directly also, I could have found the value of a as 1. However, this is the standard method which we followed. Now, we know the equation. Substituting a as 1 here, we get y equals to x minus 1 whole square minus 6. So that becomes the equation of the given parabola. Perfect. Let's move on and take the next example. So I'd like you to pause the video, answer this question, and then look into my suggestions. In this case, we want you to write the equation of the parabola in intercept form. So when I say intercept form, it means we need to find the x-intercept, right? So these are the x-intercepts which we need to figure out, and then we should be writing the equation. So here, the x-intercepts are at there are two x-intercepts. One is at -2, the other one is at 4, right? Now, since these are the two x-intercepts, we can write down the equation as y equals to a times x minus -2, it becomes +2, times x minus 4. To get the value of a, we need to identify one more point on the curve. Now, a good point seems to be right there. So we could use this or that, either one of these points. This is good. So we at -1, the point here is -10. So -1 minus 10 is the point which we are going to use. So we are going to use the point P, which is -1 minus 10. Substituting -10 for y, we get -10 here. A, x value is -1 plus 2 times -1 minus 4. That gives you -10 equals to x times, that becomes +1, and this is -9. Now when you multiply, in that case, what you get here is -9. So we get -10 equals to -9a, or -10 divided by -9 is the value of a. So a is very close to 1, not 1, but very close to 1. And we can write down this equation as y equals to 10 over 9. So minus minus cancel, you get 10 over 9, x plus 2 times x minus 4, correct? This is 10 over 9. Substituting this value, we get the answer, the equation of this parabola, as y equals to 10 over 9, x plus 2 times x minus 4. You can verify that this axis is slightly on the left side of 1, so it works out fine. It is a good practice to check your result from the graph. You can also find the minimum point to verify. Let's move on to the next question, which is again to find equation of the parabola in intercept form. So let's first find the y-intercepts and the x-intercepts. So in this case, the x-intercepts are at 3 and -1. So let's write down. So we have x-intercept at x equal to -1 and at x equals to 3. So we get these two values of x1 and x2, right? These are the two values. You could write x1 and x2. So we get the equation, which is y equals to a times x plus 1 times x minus 3. So if I substitute -1, we get a 0. If I substitute +3, we get a 0. So that is how you could check. Now to get the value of a, we need to identify one more point on this particular graph. So a good point could be the y-intercept. So it seems that the y-intercept is at 1.5. You could take this point as one of your points. So since we have y-intercept, which is at 0, 1.5, we'll consider this point to get the value of a. Substituting 1.5 for y, we get a times 0 plus 1 times 0 minus 3, which is 1.5 equals to -3a, or 1.5 divided by -3 is the value of a. So it is negative, and 2 times, right? 2 times gives you this answer, so we get -½ You could actually verify whether -½ is the right value or not by using the steps. So the vertex also we could have taken, so it really is one step down, correct? Half step down from this, right? So a is indeed equal to minus half, since it moves one step down when you move one left or one right. So this is the correct value. So we can now finally write down our answer in the intercept form as y equals to minus half x plus 1 times x minus 3. Clear? So that is how easily we can get the equation of parabola. Let's move on and take the next question, which is question number 6. This time again we need to identify the intercepts and find the equation of the graph in intercept form. I would like you to pause the video, answer this question, and then look into my suggestions. The intercepts are at minus 2 and at 4. So we have x-intercepts at, let me write this time, x1 is at minus 2 and x2 is at 4. We should identify another point on this graph also to get the final value. So this time the minimum is clearly at, well, the y value is not very clear, so we will not take that point, but we can take this point, which is minus 1, minus 10. So we'll take a point 1, which is at minus 1 and minus 10. So I'll leave this as an exercise for you. We did this similar question some time back. So I would like you to complete solution from this stage, right? Okay, let's move on and take the next question. Now here we have a graph which is restricted in the domain. Now these kinds of examples are seen many times. Let's say when you throw something up and it goes and lands on the ground. So it's that kind of a question. So it seems that this point here is the y-intercept, which is, let me say, y-intercept is 0, 1. The vertex is also very clear here. So we have the vertex which is at 1, 6. Since we know these 2 points, we can actually write in vertex form and then get our answer. So we can write this equation as y equals to a times x minus p whole square plus q. So which is y equals to a times x minus 1 whole square plus 6. To get the value of a, we will use the vertex of the y-intercept 0 and 1. That means 1 equals to a times 0 minus 1 whole square plus 6. Bringing 6 to the left side, we get minus 6 plus 1 equals 2. This will be a. So the value of a is minus 5. Let's substitute the value of a minus 5 in this particular equation. So we get a as minus 5. So we are substituting here. So what we get here is y equals to minus 5 x minus 1 whole square plus 6. Since we need to write in standard form, I have to open this bracket, right? So let's open the bracket and simplify. So we get y equals to minus 5 x minus 1 whole square is x square minus 2ab, which is 2x, plus 1 plus 6. Let's extend it. So we get minus 5 will be multiplied to all these terms. We get minus 5 x square plus 5 times 2, which is 10x, minus 5 plus 6. Combining these two terms, we get y equals to minus 5x square plus 10x plus 1. Correct? So that becomes the equation of the given parabola. So I hope that is very clear. Let me rewrite this equation here. So we got the equation as y equals to minus 5 x square plus 10x plus 1. I would like you to verify this equation. Now we are here at the last example, another parabola, and you need to write the equation in standard form. So first step, let's identify the vertex, which is clearly given to us as at -4 the value is 3, right? So this is 3 at 4, right? So at 4 it is 3. So that is the vertex. We need to find one more point. So this is a good point, which is at 3 we have y value of 2. So we have 3, 2. So from here we can find the value of, we can find the equation. So we can write the equation in the vertex form, which is y equals to a times x minus p whole square plus q, or y equals to a times x minus 4 whole square plus 3. We'll use the point 3, 2 to find the value of a. So y value is 2, x value is 3. 3 minus 4 whole square plus 3, which is 2 equals to a times 3 minus 4 is 1, square will make it positive, plus 3. Bringing 3 to the left side, we get 2 minus 3 is equal to a, or a is equal to minus 1. And so we can write y equals to minus of x minus 4 whole square plus 3. So we substituted this value a as minus 1 in this particular equation right there. Correct? Since we need standard form, we need to open this bracket. So let's open this bracket. Let me extend it here. So we get minus of x squared plus 8x, minus 8x. This is minus in between, and 4 square is 16, so plus 16 plus 3. Now we get y equals to minus x squared, minus and minus makes it plus 8x, and minus 16 plus 3 gives us minus 13 as the combined value of the constant. So the equation is y equals to minus x squared plus 8x minus 13. So that is how you could actually write down the equation. So I hope you find it interesting and useful. It's not very difficult. So we covered up how to write equations of the quadratic functions when the parabola is given to us. You could also write the characteristics and properties of the parabola. And we have seen how we can write equations in all the three forms, which is standard form, vertex form, and the intercept form. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.